All right, so this is a review about interpreting derivative graphs and knowing how to do that. So I want you to graph what I'm doing. I'm having a hard time focusing here. I'm going to try a different way. See if sometimes I go like this, and then the camera finally comes back. Can I make it focus in? Yeah. All right, so we have a function. Keep trying. And I want to be able to graph the derivative off of that. And what does it mean? And I want to be able to graph the second derivative based on that too. And what does it mean? Oh, there we go. So I think a good first step here is to draw a number line. So if I want to do a number line for the first derivative, what are the critical numbers here of f at x? Oh, I'm kind of getting off the camera. There we go. And those are your turning points. So we have a turning point at -1 and a turning point at +1. If there is a sharp corner or turn, that would also be a critical number. And what I'm looking for is increasing to -1, decreasing to +1. Oops, that means decreasing right there. And then after +1, increasing. So these signs describe increasing, then decreasing, then increasing. So when I graph here at -1 and at +1, my turning points are x-intercepts here for the derivative. And positive means it's above, and the negative means it's below. Now, one more thing here. We have a point of inflection at 0. So at 0 is a turning point. So the turning point for the derivative describes where the point of inflection is. So it's above, below, above. The x-intercepts are the x values of the turning points. And the turning point of the first derivative is the x value of the point of inflection. So this is concave down, and then it changes to concave up, and there it is. How about the second derivative? So what are the key points here? So when I look here, the only key point is the turning point here of the first derivative. So 0 describes the only critical number, the turning point for the first derivative for the second. And then I'm looking for decreasing, which is negative, and then increasing, which is positive. We could also go from the original and go concave down is negative, and then after 0, concave up is positive. So at 0 is an x-intercept. It describes the point of inflection, and it's below and then above, and it's done. So this describes concave down, concave up, point of inflection. This describes the turning points. It's increasing, then decreasing, then increasing. This turning point is this. They describe that point of inflection. And this is all of it together. Concave down, concave up, increasing, decreasing, increasing. It's all put together. Let's try one more example. Then you have your quiz. So here we have the first derivative. So I want to, well, let's go this way, then that way. So let's do the second derivative and then the function. So in order to do the second derivative, I'm going to do a number line and look. And what I'm looking for is a turning point maximum. Actually, here is a sharp corner. So that value at 0 is the only critical number for the second derivative. And then it's increasing, and then it's decreasing. Now, what I recognize here at 0 is the derivative at 0 is actually undefined because it's a corner. So at 0, it's actually a hole. Now, because these are lines, I actually know the number of where it's going to. I want you to remember that derivative means slope. So what's the slope of this? So it went up 2 and over 2. The slope of this is +1. So I want you to find +1, and you're going to draw a line up to 1, but once we get to there, it's going to be a hole right there. So the derivative of this part is 1. There it is. But when you get there at 0, it's undefined, so it's a hole. On the other side, the derivative is negative 1. So here we have the slope is positive 1, the slope is negative 1, but at 0 is a hole, and the reason the derivative doesn't exist, you can see left side doesn't equal right side. All right. How about the next part, which is could you graph the function based on these? So what would f of x look like? So I already have that number line. Can we do the other number line for the first derivative? And then put it together on here. So what are the critical numbers here are negative 2 and positive 2. And it's below, then above, and then below. This describes decreasing, then increasing, then decreasing. All right, so on our graph, I don't know where the intercepts are, so I'm not even worried about that. But I do need to know where negative 2 and positive 2 are. So if I look at this number line, there's a minimum at negative 2, and there's a maximum at positive 2. I don't know where the minimum or maximum is, but I do know one is lower and one is higher. And then at 0 is a point of inflection. So this is concave up and decreasing to begin with. And it's concave up to 0. So this is concave up, decreasing, and then after negative 2 is increasing. Then it's concave down. So it's concave down, and again it changes from increasing to decreasing at positive 2. We have a minimum at negative 2, a maximum at positive 2, concave up, concave down. It all matches these number lines. All right, there's your quick review on derivative graphs. Good luck. Mr. G Math, over and out.